Hello everybody, today we're going to discuss the second part of stepwise regression that we discussed in the previous tutorial. So that today we'll continue our lesson using the olsrr package. So I already imported my data as well as I already ran this package in order to save our time. So the first step that we're going to use is to get all the possible regression. So in order to use that, you have to use ols underscore step underscore all underscore possible and write the model that you created. That means the model that used all the predictors into this parenthesis. If you remember, all means this one. So you have to submit this package. This syntax. GUI stands for response variable as explained by the remaining predictors that found in our data. So type this and submit to our studio. Then the first function, this function, that means highlighted function, helps you to get all possible regression. For example, we have 10 predictors, so that we are going to expect to have what? 10 raised to the power of 10, which is around 1000, yeah, 1024 possible regression. So this helps us to get all the possible regression combination. So type this and submit to our studio. Then it will take some time, as it depends on your processing on your computer processing system, so that this will give the R-squared, adjusted R-squared, as well as the Mallows CP. The Mallows CP will help us to select or to identify the best model. So the Mallows CP is best when it is approached to your number of predictors. Yeah, the result is already output in this way. As you can see, here is the predictors. For example, the first predictor is TT, the R-squared value is 0.75, the adjusted R-squared is 0.74, and the Mallows CP is 11.6. So this number is too huge, so it is biased. That means, in order to say it's good index, when the Mallows CP is equals to or around to your number of predictors. For example, our number of predictors here is TT, which is 1, so we are expecting Mallows is around 1 or 2, but here is 11, which is a big number. Then the problem with R-squared is for every unit that you increase the predictors, R-squared tend to increase and never increase. So adjusted R-squared helps us to minimize this effect. That means adjusted R-squared will only increase its value when the added model or the addition of model when it becomes significant effect. So unless otherwise, it would never increase. So by this way, it will penalize the R-squared value. Coming to the second one is in order to select the best regression. In order to that, you have to use this function. That means the highlighted function is help us to select the best regression on the basis of a number of statistical concepts. So type this and submit to our studio. As I mentioned before, we have 1024 regression possibilities, but this will help us to select only the best one. That means the best regression model. So let's wait our result. So here are a number of statistics. For example, the first one is R-squared, then adjusted R-squared, predictor R-squared, the Mallows CP, a kicking information criterion, and the Stepwise Bayesian criterion, the Schwarz Bayesian criterion, the estimated error prediction, as well as here is the final prediction error. It means which is similar to a kicking information when you have a large number of data set, as well as here is the Hawkins SP method, and lastly the AMEA prediction criteria, which helps to strictly penalize R-squared value comparing to adjusted R-squared. And adjusted R-squared and predicted R-squared help us to penalize the R-squared value, because there are two major problems of R-squared. The first one is for every predictor added to the model, R-squared always increase and never decrease. So it can be appear to be better to fit with more terms you add to the model. So this can be completely leading to a wrong or invalid conclusion. And the second one is if your model has too many terms and too many high order polynomials, so you can run into the problem of overfitting of your data. So when you overfit your data, so there again you are doing a wrong conclusion. So you are misleading people with high R-squared value, then this to lead this again to mislead to a great projection. So this is a two problems. The first is R-squared always increases for every added of predictors. The second one is it create a problem of overfitting of your data. So adjusted R-squared is penalized in this way, and in similar fashion, the predicted R-squared also do in this way. And the predicted R-squared helps us to determine whether you are overfitting of a regression model. So again, overfit of model includes an excessive number of terms or predictors, and it is begin to fit a random noise in your sample. In fact, it's not possible to predict random noise, but if your model fits a lot of random noise, so you just check the predicted R-squared value. That means the predicted R-squared value must fall. So a predicted R-squared that is clearly or significantly smaller than the R-squared, that is showing you a warning sign or a warning light that you are overfitting the model. So you have to try to reduce the number of terms. And the rest are, this is the Mallows CP I already mentioned. So the rest are, that means a kicking information criterion, the Bayesian information criterion, even also this one, which is this and this model are, that means a kicking information criterion as well as the Akikin final predictor error are coined by the same person who is called Akiki, and this also helps us to reduce to help us to select model selection. So mostly Akikin information criteria is preferred and widely used. And the other one is similar, for example, like this also the Hawkins SCP also the important criterion which help us to select your model. So by this way you can select the best regression method. In addition to that, the AMEA's prediction criteria is strongly, or it is heavily penalized the R-square value as compared to adjusted R-square as well as the predictor R-square. So accordingly, the best model, the best model here is, for example, model 1 means it is a combination of what? The combination, actually model 1 is only with TT predictor. The second one is, for example, let's take model 8 means it is the combination of what? These predictors. Yes, as you can see here is a predictor. Model 10 means it's a combination of all these predictors, and model 7 means it is a combination of all these predictors. So these are the best combination or the best subset regression summary. Next to that, you can go for the forward selection. In order to create the forward selection, you have to use OLS step forward P function. Then you have to indicate the model. Then you have to indicate the P inter. P inter is equal to 0.05 means enter the value or the P values that have less than 0.05, and detail is equal to true. It will give you all the steps that used in the model selection. So type this and submit to our studio, so you will get. Let me erase this first and let's deal with this. So let's do the forward selection. So it only provides those value are what? Significant. For example, the candidate terms are here are 10, or the predictors are 10, then it selects on the base of what? On the base of the P value. So on the base of P value, TT, the predictor TT are significant. So it entered to our model. Again, the second one is the PT. When we see the p-value of PT, again it is significant, so it again entered to our model. Then finally, there is no more predictors or variables that are entered to our model because no any other predictor other than 2, that means that TT and PT are statistically significant or less than 0.05. So we include TT and PT in our model in this way. Yes. So these are the summary. Here is the intercept, and you have to use the coefficient, and by this way you will predict. That means gradient is equal to 39.68 minus 3.19 tt, again minus 1.508 pt. So by this way we can set the forward selection in our model. The second one is we can also check using the plot. So type this and plot, then write the name that you assigned here. I assigned here is M, so when I plot this, I will get these types of image. Yes. This is a plot too. That means the SBIC, that means the Bayesian criterion. So the least Bayesian criterion is selected or preferred. So when it is around 2, it will give, which is less than 67, around 60 or 50 something. Similar concept to this one. Yes, the second one is this one, the R-squared value. It will take time. Sorry. Yes. Here is R-squared value is tend to increase sharply around in the 2 predictors. Around it's found here is 2. Again, the adjusted R-squared also is best around 2 here. But the Mallows CP tends to around the model 2 is good. When the model is 1, it's around 12. This is not advisable. In similar fashion, in Akikin information criteria, when the model is around 1, which is found the Akikin information criteria is 166, but it tends to, when we increase the model around 2, to decrease 156. So the least Akikin information criteria as well as the least Mallows CP is advisable, and in similar fashion, the highest R-square as well as the highest adjusted R-square also is advisable. So by this way, also you can select your forward selection. So let's continue to backward selection. And in order to get the backward selection for stepwise regression, you have to use OL step backward then P. Why we select P? Select on the basis of what P value, then you have to indicate the model here, then P remaining is equal to 0.08. So those predictors or variables containing less than the p-value of 0.08 will be included for backward selection, but the remaining will be removed from the model. So type this and submit to our studio. This helps us. So I think this is redundant, which helps us for to get detailed information. But if you don't want to see the detailed information, you just omit this syntax, including the comma and close with bracket, or just type is equals to in the form of here in the form instead of true you have to say false. So by this way you can get the backward stepwise regression. So on the basis of this, around 7 variables are removed and only 3 variables are included. But that means the GPC, the SY, and the TT are selected on the basis of what p-value. So p-value greater than 0.08 will not be included in this model. So these are similar concept. So it's just simply select models that have greater than 0.08, but those who have less than 0.08 0.08, it will be included in the model. Then the third is using Bose selection method. So in order to do that, you have to use ols underscore step underscore Bose, then P. You have to say P, then select the model. Then you have to set here enter. P enter is equal to 0.05 means just containing p value of 0.05, that means less than 0.05, it will be included in the model. Then remain as well as 0.08. The tail is equal to true. This will yield you the backward, the Bose selection. So under such circumstances, it will give you detailed information. So this model only included what? P value less than 0.05 and it remain P value 0.08. So by this way, we can get these two variables in our model. So here is the coefficient that we are going to use. So on the basis of the Bose selection method, gradient is equal to 39.686 plus negative 3.19 TT minus negative 1.508 will be our model formulation. So we select on the base of what p values. As you can see, here is a p values in the end of all selection method. Here is p, again here is p, and here is p. That means for the forward selection p, and here is p, and here is p. But now we will convert into a kicking information criterion. In order to do that, you have to use the similar things OLS step forward. Then you have to use what? AIC. So this will select us our model on the base of what? A kicking information criterion. So for forward, you can say forward. For backward, you can say backward. So let's use all this function, and then you have to indicate your model name, then detail is equal to true. So type this and submit to our studio. You will get this result. So on the basis of this result, let me start from step 0. Still we are waiting. Yes, here is the forward selection method. There are 10 predictors. Yes, obviously we know that. Then step 1, step 0, you can start from a key information criterion 208.755. So you will select the least value. From this value, we get what? 166. It will be included in our model. So TT will be selected. Then go further. Then here is the a kicking information criteria is 166. So select the value that are less than the least one. So here is 156 is less than. So we will include it. Here is the PT. Initially we selected this one, then we'll add PT in our model, then continue. So our model is building in this way. Then the third one is 156.01. So the values that are less than 156 are the 2. So we will select the least one, that means TKW. So it will be included in our model. Then we proceed here. So the key information criteria given is 155.4766. So as you can see here, there is no values that are less than 155.4766. So we stop only by building our model using the three predictors, that means the TT, the PT, and the TKW. And no more variable is to be added. Why? Because there is no values that are less than 155.476. Go for backward, and similarly, it is the same formula, but you have to change here is the backward. So type this and submit to our studio. And even you can get here is the plot for the key information criteria for the forward selection. Yes, the plot is already displayed here. Yeah. So on this basis, TT, PT, and TKW are selected. in very easy way. Coming to the backward, in the case of backward, you have to use OLS step backward, then AIC, and all the remaining things are the same with that of forward selection. So type this and submit to our studio, you will get this result. So this is a backward or this elimination. Let's drag, yes. So there are 10 candidates. Then the list, for example, the value that are here is step 0 is 163.7098. So the values that are less than this is the least one is 161.727. So PT will be removed from the model. As you can see, here is a 10 candidate term or the 10 predictors or variables. So from this, we removed this one. Then continue to the rest one. Again, 161.72, then the value that are less than from this is the least one is HI. As you can see, here is 159.785, so HI will be removed from our model. Again, then this will be removed. Then again, the key information criteria is here 159.78. Then the values that are less than this are the 2, or here is the 3, but the least one is pH. pH will be removed from our model. Then continue in this fashion, 157.99933. Then again, the least one is 156.269, which is the variable name is HLW. So HLW will be removed from this section. Then continue till the end. So in the end part, here is AIC is 154.1194. So there is no value that is less than in this model. So we will stop here. Then we removed, generally we removed 1, 2, 3, 4, 5, 6, 7 variables, and remaining for what? For 3 variables only. What are the 3 variables? That means TT, SY, and GPC are remain in our model. So the final model output will be in this way. Here is the beta. So gy, which is equals to 9.618 minus 3.917 TT plus 1.226 of SY, then plus 2.936 of GPC will be our model for backward selection. Or you can easily just type plot is equals to W. W is what we created for what? For the backward selection. So it will show you the removed predictors from our model. So 1, 2, 3, 4, 5, 6, and 7. These models are what? Removed from our model on the basis of what? A key information criterion. Here is the full, but remain with 3 models or 3 predictors to build the model. Coming to the Bose selection method. So in order to do that, you have to use OLS step Bose AIC. So instead of backward or forward, you have to use Bose, the function. So all things are the same. So type this and submit to our studio. Again, on the concepts are the same. Then the final model here is TT, PT, and TKW. Alternatively, you can use the graphical approach. So plot in the parentheses, type right. Type Y. Y is what we created here. So type this and submit to our studio. It will show you the predictors that are added to our model. So here is the TT and PT and TK and W. So this is all about today's tutorial. I hope you get important information about stepwise regression in the previous tutorial as well as in today's tutorial. So as usual, if you have any question, comment, suggestion regarding to my tutorial, you can address me through my email as well as YouTube comment box. So I will provide all the codes and the package in a description box. Thank you for watching. Have a nice time.